this video, we'll continue our review of polynomials by continuing with graphing a polynomial, and then we'll also look at some division, finding zeros, and a little bit more about parabolas. To start with, if I want to graph a polynomial, I'm going to start by looking at the lead term. Now this lead term is x cubed, which is positive and odd degree. So it's going to behave like a cube function, a positive cube function. So it's going to fall to the left and it's going to rise to the right. So that's this answer here. If I want to find the x-intercepts, then I'm going to set the function to 0. So let f of x equals 0. And then I'm going to solve this. So to solve this, what I can try is I can always try factoring, and this one does in fact factor. I'm going to use factor by grouping since there's 4 terms. So the common factor for the first 2 terms will be the x squared. Common factor for the last 2 terms will be minus 1. Here's what that would look like. X cubed divided by x. X cubed divided by x squared is x. 4x squared divided by x squared is plus 4. And then minus 1. The opposite of x divided by negative 1 is x. Negative 4 divided by negative 1 is plus 4. So this factors as x squared minus 1, x plus 4, which is x plus 1, x minus 1, x plus 4. And if this is equal to 0, then I've got x plus 1 equals 0, so x equals negative 1. X minus 1 is 0, so x equals 1. X plus 4 is 0, so x is negative 4. So our zeros, or our x-intercepts, negative 4, negative 1, and 1. I could graph these negative 4, negative 1, and 1. We know that the graph is going to cross the x-axis at those 3 points. To find the y-intercept, that's even easier. I'm going to replace the x with 0. So we'll have 0 cubed plus 4 times 0 squared minus 0 minus 4. So replace the let x equal 0. We'd have 0 cubed, 0, 0, and this all turns to 0 plus 0 minus 0 minus 4. So the y-intercept is negative 4. So we could say that when x is 0, y is negative 4, and that's this point right here. So putting this all together, if I know we're falling to the left, I know we're rising to the right, I could get a pretty good grasp of this, of what this looks like. I might be interested in seeing what happens, like how high up it goes. So you could find f of negative 2, f of negative 1 to get a few more points if you wanted something more precise. But for what we're doing, this would be sufficient to see that it does something like this. Let's look at another type of example. We could use synthetic division and the remainder theorem to find f of negative 2. Now you might be tempted to plug in a negative 2 for x, and that would give you the value of f of negative 2, but you'd be missing the directions here that say to use synthetic division. So by using synthetic division, here's what I'm going to do. I'm going to divide by a negative 2, so I'll take out the coefficients 6, negative 7, 3. And the process for synthetic division is we drop down the 6, and then it's multiply and add. So 6 times negative 2 is negative 12. I could just keep that running total on my calculator. Don't delete it, because negative 12 times negative 2, or I'm sorry, we got to add first. Negative 12 plus negative 6 is negative 18. So let me walk through what we did. We dropped down the 6, and then 6 times negative 2 is negative 12. Negative 12 plus negative 6 is negative 18. Multiply. Negative 18 times negative 2 is positive 36. Plus negative 7 is 29. 29 times negative 2 is negative 58. Plus 3 gives us a remainder of negative 55. So this tells us that f of negative 2, let me show you that. Negative 2 is what we divided by. So this tells us that f of negative 2 is equal to negative 55. It's equal to the remainder. That's the remainder theorem. So it'll become really helpful, really powerful when we're going to find zeros in the future, right? So make sure you're familiar with that. Let's try this next example. For this polynomial, it's already factored for us. We can tell a little bit about the graph and get some basics. It's already started for us. This is like that first example we did in the video that was numbered number 2. It's like that, but even a little simpler because some of the information is already given to us. So determine, without graphing, whether, oh, you know what, I'm realizing this part that's pasted in is not what's matching up, so let me fix that. Okay, so the first thing we can do is use the lead coefficient. Now, if I counted up the degree, we have a x squared times an x times an x. That's going to give us x to the 4th. This is going to give us a degree 4, and the lead term is positive. So it's positive and even. So its end behavior is going to be like that of a parabola. It's going to rise to the left and also to the right. Next, I could find those x-intercepts. This is going to be the easy part because it's already factored for us. If I set each factor to 0, if I let x minus 2 equal 0, I'd get that x equals 2. Now this power of 2, since it's x minus 2 squared, you could think of it as x minus 2 times x minus 2. So that means that x equals 2 is a answer twice. So what we say about that is x equals 2 is the x-intercept. But we can say that if we were talking about this as a 0, we could say that it has multiplicity 2, right? And then x plus 1 gives us the 0, x equals negative 1. X minus 4 gives us a 0, x equals 4. So I could graph these points 2, negative 1, and 4. There's our zeros. And then the y-intercept, if I let x equals 0, I'd have 0 minus 2 squared, 0 plus 1, and 0 minus 4. So negative 2 squared would give us 4 times 1 times negative 4, or negative 16. So I know that we cross the x-axis at, or the y-axis at negative 16. Y equals negative 16. And this is going to actually give us enough to get a rough sketch of the graph. Oh, sorry. What was I? doing there? Let me back up just a bit. This, which one had the multiplicity of 2? That was, let me circle it. The multiplicity of 2 means that when I hit that, I'm going to touch it and then fall back down. So to fit all of this together, we've got to be going up on both ends. We've got to get to all 3 of these intercepts and also get the y-intercept. So I know I've got to bounce back someplace, and the bounce back comes with that multiplicity of 2. So the graph would look something like this. Just a couple more examples in this video. We could use the vertex and intercepts to sketch a graph. So if I were to sketch this graph, the vertex, I could use the formula x equals the opposite of b over 2a. A is 1, b is -6. So we have the opposite of -6 over 2 times 1. So +6 divided by 2 gives us 3. So we know that for the vertex, the x-coordinate is 3. To find the y-coordinate, I can find f of 3 is going to be x squared minus 6 times x minus 16. So plugging in that 3, f of 3 is going to be 9 minus 18 minus 16, or -25. So it looks like our vertex is x is 3, y is -25. And then the intercepts, if I let x equal 0, I'd have 0, minus 16, or in other words, 0, -16. So I could graph these points. The vertex 3, -25. Oh, I can see, let me get a different graph here. So here's our vertex 3, -25. And then we can find this additional point when x is 0, y is -16. So if I find that point, that was 1, 2, 3 over from the vertex, or from the axis of symmetry, right? So if I go 3 to the right, I'd have another point that I could graph. I could also find x-intercept of -2, and I could use that to graph as well. And that gives me an even fuller picture of this graph, which looks something like this. From this, I could determine that the domain is -infinity to infinity, because it's a polynomial. And I can see that the range starts at -25 and includes -25 and goes up to infinity. Another example we can use the zeros and give the multiplicity of each zero to determine whether this touches and bounces back, or if it crosses through. So I'm going to start by factoring this, and I can factor by taking out the common factor of x squared for the first 2 terms, factor the -4 out from the second 2 terms. If you need a review of factoring, well, then you can find that on Canvas or also on MyLab Math. But the factoring method I'm using when there's 4 terms is factor by grouping, in factoring out x squared, I'm saying x cubed divided by x squared is x. And then 8x squared divided by x squared is 8. So I can write x cubed plus 8x squared is x squared times the quantity of x plus 8. And then I could do the same thing with this negative 4. Negative 4x divided by negative 4 and negative 32 divided by negative 4. We're going to get negative 4x squared divided by negative 4 is x. Negative 32 divided by negative 4 is positive 8. And when I notice that these two factors match up, we have an x plus 8 times x plus 8, that now becomes our common factor. So I could factor out the x plus 8, and we're left with x squared minus 4. That x squared minus 4 factors again as x plus 2, x minus 2, the difference is squares. And so that's our polynomial in factored form. So it looks like we have 3 zeros and they all have multiplicity 1 because none of them have a squared or cube or other degree. So we just have x equals negative 8, multiplicity 1, and that means it crosses the axis. X equals negative 2, degree 1, so it crosses. To bounce back, it'd have to have an even multiplicity. And then x minus 2 gives us the 0, x equals 2, and it crosses the axis. Let's look at another example, long division. For this example, we're going to divide by x plus 3. And what are we dividing? We're dividing the 3x cubed plus 13x squared plus 16x minus 10. And to do that off to the side on the scrap paper, maybe, but not on a throwaway scrap paper. So you might just draw a line on your paper to distinguish that. We're going to take this 3x cubed and divide it by x to get 3x squared. And that is going to be our first term for the quotient. I'm going to write it in the x squared column. So I'm going to write it above the 13x squared, so we have 3x squared. After you divide, the next step is to multiply. So I'll multiply that 3x squared times our divisor, this x plus 3. And when I distribute that, so multiply, I'd get 3x cubed plus 9x squared. 3x cubed plus 9x squared. Now pay attention to what's going to happen next, because if you recall, the next step is going to be to subtract. I've got to subtract the 3x cubed and subtract the 9x squared. And this subtracting the 9x squared tends to be a common mistake. You want to make sure you're distributing that negative to both the 3x cubed and the 9x squared. So here we cancel out 3x cubed minus 3x cubed, but for the x squared term we have a 13 minus 9, which gives us positive 4x squared. And then we're ready to start all over again. So once we do the subtraction and get 4x squared, we're going to bring down the 16x and start all over. So we have 3x squared is our first term of our, quotient. To get the second term, we bring down the 16x. We start all over again. So we'll take our 4x squared and we're going to divide that by x. That's this, we're dividing by x plus 3, but to get the quotient, we can take just the first term, the 4x squared, and the first term, the x, and divide those. So we'd get 4x. So that's the next part of our quotient. We'll put the 4x on top of the bar, multiply by our divisor, x plus 3 gives us 4x squared plus 12x. And now we're going to subtract that. So we subtract the 4x squared and subtract the 12x. So the 4x squared minus 4x squared, those cancel out. But the 16x minus 12x gives us a 4x. Now we'll try it one more time. Is we'll bring down this negative 10, but we'll divide the 4x divided by x and get 4, multiply it by the x plus 3 to get 4x plus 12. And then when I subtract that, I'm subtracting 4x and subtracting 12. Be really careful with the subtraction here because we have a negative 10 minus 12 is going to be negative 22. Oh, and it looks like I forgot to write that 4 up at top, so let me make sure everyone follows where the 3x squared, the 4x, and the 4 all came from. When we did the 3x cubed divided by x, we got 3x squared. When we did the 4x squared divided by x, we got 4x. And then the last one, 4x, this 4x here, this blue 4x divided by x gave us the 4. Don't forget to write that 4 up here. And then we multiplied 4 times x plus 3 to get 4x plus 12, subtracted to get negative 22, which is our remainder. So I could write the final answer as the quotient q of x is 3x squared plus 4x minus 44, and the remainder r of x is negative 22. That brings us to the end of this review. This was the part 2 video. There were 2 parts, 12 problem types total. Some of them were done with multiple versions. So if you do have any questions about any of those problems, I hope that you'll reach out to me to let me know how I can help you better understand any of these important topics with review of polynomials.